Hello everybody, welcome to Tracy Learning Physics videos. Today we'll be discussing about derived units, and in that we'll be covering the topic, concept and explanation related to derived unit. This is the first video related to concept and explanation. So let's see what all topics we'll be covering in this video. In this video we'll be discussing about what are derived quantities, what are derived units, explanation of derived units with example, list of derived units, and list of derived units with special name. So let's start. First of all, what are derived quantities? Derived quantities are those quantities which are dependent on other quantities for their measurement. So here we are talking about the derived quantities which are dependent on other quantities for their measurement, for their existence. And if I'm talking about what kind of quantities they are dependent on, so these quantities can be derived from fundamental quantities by either multiplying or dividing them. What I'm trying to say here is that these derived quantities are nothing but the result of some systematic equations resulted from either multiplying or dividing these fundamental quantities. So that means without the presence of these fundamental quantities, or without using these fundamental quantities, we cannot get these derived quantities. So now the question arises, like, what are the examples? What kind of derived quantities I can think of? So the quantities like speed, pressure, and energy are known as derived quantities. So now if I ask you why, how I can say that speed is a derived quantity, or a pressure is a derived quantity, or energy is a derived quantity. So here I'll just explain you. First of all, I'll take an example of speed. What is speed? Speed is nothing but its distance upon time. So if I think about the fundamental quantities about which I have discussed in the fundamental quantity video, we know that the distance and time are fundamental quantities. So you can see here that the speed is dependent on distance and it is dependent on time, which are two fundamental quantities. So that means dividing distance by time, we get speed. That means dividing one fundamental quantity by another, we get the derived quantity, which is speed. Sometimes what happens, it doesn't stop at the one level, it goes further and further and further. So for that I would like to give you an example of pressure. Now what is pressure? Pressure is force upon area. Unlike distance, force is again a derived unit, so it will not stop here. We have to move further, we have to go deeper unless we get the fundamental unit. So let's see here, like I'm taking pressure is equals to force upon area. Now what is force? Force is mass into acceleration. Now mass is the fundamental quantity, whereas the acceleration is again a derived quantity. So now what is acceleration? Acceleration is velocity upon time. Now time is a fundamental quantity, whereas velocity is again a derived quantity. Velocity is equals to displacement upon time. Now this displacement is a fundamental quantity and the time is fundamental quantity. So you can see here that we have to go down to the fundamental quantity. From the fundamental quantity we are getting these derived quantities. So it may end at their first level, or we have to move further and further and further unless we get the fundamental quantity. So this is the reason like the quantities like speed, pressure, and energy are known as derived quantities, because as we have seen here that they're dependent on other quantities for their measurement. What are derived units? Derived units, the units associated with derived quantities, are known as derived units. We have discussed about the derived quantities. So the units associated with them are known as derived units. So there are 2 points related to derived units. First, they can be derived from another, that is, they are dependent on any other unit, as we have discussed earlier. And the second point is can be changed into any other units by mathematical calculations. To make these 2 points understand, I'll take an example here. I'll take an example of this hunting leopard. You can see here in the image that this leopard is running. So if I take the velocity of this leopard, we know that velocity is displacement upon time. Displacement is a fundamental quantity and the time is the fundamental quantity and velocity is the derived quantity. And the fundamental unit of displacement is meter. The fundamental unit of time is second. So the velocity in terms of fundamental units will be meter per second. Now if I have to write velocity in terms of say kilometer per hour, then I have to do necessary mathematical calculations, that is the conversions to get the value in kilometer per hour. That means I have to convert meter into kilometer by dividing it by 1000, and I have to convert the second into hour by dividing it by 3600. So if I just calculate it, it can be kilometer by 1000 and hour divided by 3600. So this will come out to be 3600 upon 1000 kilometer per hour. And this will come out to be say some value. I've not given any value, so I'm just writing it 18 by 5 kilometer per hour. So here if I have some value, I can just x value, I can just multiply by 18 and get it divided by 5 to get the value of velocity in kilometer per hour. So these are the 2 points you need to understand when we are talking about derived units. So the bottom line we can say is that derived units are dependent on fundamental units and can be expressed in terms of fundamental unit. Part 1 ends here.